In this video, we're going to solve problems involving plane areas by integration. Number 1. Calculate the area of the region bounded by the line y is equals to 8 minus 2x, the x-axis and the y-axis. So let's start sketching the graph of the line. So y is equals to 8 minus 2x. Let's get the x and y intercept since we're dealing a linear equation. So if we replace x with 0, so that is y is equals to 8 minus 2 times 0. So 2 times 0 is 0. So 8 minus 0 is basically 8. Let's change the color of this one. So if we replace y with 0, so 0 is equals to 8 minus 2x. So we transpose 8 to the other side, so it will become negative 8. Negative 8 is equals to negative 2x. So let's divide it by both sides, so negative 2. So we cancel this one, so negative 2 and negative 2. And we left by negative 8 divided by negative 2. Meaning the answer will be 4. So our x-intercept is 4. So if we have y-intercept of 8, so we have y-intercept of 8. Sorry. So we have y-intercept of 8 and x-intercept of 4. Let's find the area between this one. The area of this one between this line, the x-axis and the y-axis. So the one way for us to get the area of this bounded region, since the bounded region is a triangle, we can use a basic or simple geometry, which is the area of the triangle. Like I said before, the bounded area that formed is a triangle. So area is equals to 1/2 times base times height. So now our base will be 4 and our height is 8. So 1/2 times 4 units times 8 units. So 8 times 4, that is 32, times 1/2, that is 16 square units. That is the answer of the bounded is the area of the bounded region. But let's use the calculus to get the answer well. We know that the area between a curve and x-axis is gonna be the integral from a to b of f of x and the integral from a to b of f of x dx. And as we know y is equals to f of x, and y is equals to 8 minus 2x. So we can replace f of x with 8 minus 2x. And along the x-axis, this one, and this one, the point of origin. And along the x-axis, we are going to integrate 0 to 4, this one. So we're gonna integrate it from 0 to 4, from 0 to 4 of f of x, which is our 8 minus 2x, and then dx. The antiderivative of 8, that is 8x, and the antiderivative of 2x, that is 2x squared over 2. We can cancel 2 from the and evaluate it from 4, 0. So let's plug in 4 from the expression. So 8 times 4 minus 4 squared minus, minus, let's plug in 0 from the expression 2. So 8 times 0, 0 squared. Let's solve for the answer. So 8 times 32 is basically 8 times 4 is basically 32 minus 4 squared, that is 16, and the rest is 0. So 32 minus 16 is 16. So as you can see that the answer is the same from the other one. Now we can also get the same answer in terms of y as opposed to in terms of x. So we can integrate from now we can also get the same answer in terms of y as opposed to in terms of x. So we can integrate from c to d in terms of integrate from c to d using this formula. Take note that the x is equals to f of y. So what we are going to do to get the function of y is to solve for x. So y is equals to 8 minus 2x minus 2x. So let's transpose negative 2x from the other side. So we get 2x is equals to, and y to the other side. Let's transpose it also from the other side. So 8 minus y. So divide by both sides. So 2, and divide also from the rest. So so for x, so 4 minus 1 half y. So therefore we can say that f of y is equal to 4 minus 1 half of y. We're going to integrate it from c to d, or 0 to 8. F of y, which is 4 minus 1 half y, and then dy. So antiderivative of 4, that is 4y, sorry, minus 1 half y squared over 2, evaluated from 8 and from 0 to 8. So let's simplify this one. So 4y is equal minus 1/4 y squared, evaluated from 0 to 8. Now let's plug in the values from the expression. So 4 times 8 minus 1/4, so 8 squared minus, let's plug in 0, so 4 minus 0 minus 4y 1/4 and 0 squared. So let's solve 32 minus 1/4 times this. So 8 squared, that is basically 64. So 64 divided by 4, that is 16. 16, and the rest 4 times 7, and the rest will be 0. So 32 minus 16 is 16 square units. Find the area of the region enclosed between the curves y is equals to x squared and y is equals to x plus 6. So first, let's sketch the graph of these two expressions. We know that y is equals to x squared, y is equals to, sorry, y is equals to x squared is the equation of the parabola. So let's draw a Cartesian plane here. So we all know that y is equals to x squared is the equation of the parabola, which is symmetric about the y-axis and vertex is the origin. It should be like this. Sorry about my drawing. And y is equals to x plus 6 is the equation of the straight line, which makes an angle of 45 degrees with the x-axis and having the intercepts of -6 and 6 with the x and y axis respectively. So let's draw 1, 2, 3, 4, 5, 6. The graph of y is equals to x plus 6. So the graph of y is equals to x plus 6 is like this. So how can we determine the area of the region bounded by these two curves? So in order for us to find the area of this one, the area of this region bounded by these two curves is to find the point of intersection, which is this one and this one. So how can we find this point of intersection? So let's set these two expressions equal to each other. X squared is equals to x plus 6. So transpose x plus 6 and from the other side. So it's going to be x squared minus x minus 6 is equals to 0. As you can see, it forms into a quadratic equation. So how can we find the point of intersection in this kind of expression? So we're going to use factoring. So what are the factors of 6 and then of negative 6 that adds up to negative 1? So that is negative 3 and positive 2. So it's going to be x minus 3, x plus 2. So that is our point of intersection. X is equals to 3, x is equals to negative 2. That is our point of intersection. Now that we know the point of intersection, we can solve the area using this formula. Area is equals to the integral from a to b, where b is greater than a, the integral of a to b, which our x values of the upper function f of x minus g of x dx. So in this formula, what will be the value of f of x? So let's return to the graph. The f of x, and like I said before in the formula, that the f of x is the upper function. So which one is the upper function? Is this, it's x plus 6. This one, the line and the upper function will be this one, x squared. Now that we know the value of f of x and g of x, we can now solve the area of the bounded region. So the integral from a to b, where b is greater than a, so our value of b is 3 since it's greater than -2. So 3, sorry, start of 3. Ooh, it's a big one. 3, the function x plus 6 minus x squared dx. So let's integrate first x plus 6 and x plus 6 minus x squared. So the antiderivative of x, that is x squared over 2 plus 6, the antiderivative of 6, that is 6x, and the antiderivative of x squared, that is x cubed over 3, evaluated from -2 to 3. Now let's plug in 3 from the expression. That is 3 is 2 over 2 plus 6 times 3 minus 3 raised to 3 over 3 minus, so let's plug in -2 raised to 2 over 2 plus 6 times -2 minus -2 raised to 3 over 3. Now let's solve. Let's solve for this one. So 3 raised to 2, that is 9 over 2 plus 18 minus 27 over 3. So 27 divided by 3, that is 9, minus 4 over 2, that is going to be 2 plus -12, sorry, 6 times -2, that is -12, and so -2 raised to 3, that is -8 over 3. Since there's a negative in the other side, we will multiply it and turn into positive. So 8 over 3. Now let's put it on the calculator. So 9 over 2 plus 18 minus 9 2 minus 12 plus 8 over 3. So the area of the bounded region is 125 over 6 square units. That is the answer. Or 20 or or that is 20.8 square units. Okay, number 3. Find the whole area bounded by the circle x squared plus y squared is equals to a squared. So, let's sketch the graph a bit of the x squared plus y squared is equals to a squared. So the circle is asymmetrical about both the axes. So the whole area is 4 times the area of the circle in the first quadrant. So um so the point so the center will be the 0 here, point of origin. So it will be like this. Sorry about my drawing. Assume that it's a circle. The center is in the point of origin. So like I said before, the circle is symmetrical. So basically the whole area is 4 times of the area of the circle in the first quadrant. So yun. So this one. So area of the circle. Area of the circle. So 4 times the area of the first quadrant, which is 1/4 times the area of the whole circle. Area of the circle, that is pi times r squared. So how can we find the area of it? So cancel this one. We have pi r squared. That is the pi r squared square units. That is the